Welcome to my channel. Your tutor Mariam is here. It's the 8th video of Introductory Physics 1 and the third video that I'm going to talk about the motion, which is a second subject of Introductory Physics 1. In this video, I'm going to talk about the motion diagram, and at the end of this video, we're going to look at one example. So if you are new to Introductory Physics 1, hit the subscribe button and like for more. You ready? Let's get started. So let me talk about the motion diagram first. So here we are looking at three different diagrams and each one has the different meaning. Let's start from the one on the left side. So here we have this plot as the displacement and time. So if I have this plot, I can calculate the velocity, right? Because velocity is gonna be the derivative of x over time, right? For the second one, if I have the velocity, I can calculate the acceleration, correct? And the last one is a plot based on the acceleration. Okay, so what you usually see in your textbook is gonna be the plot like this. So you have the displacement, velocity usually show with the straight line, and same as the acceleration. You usually see the straight line. But my point here is like you can see the same plot with a different meaning because they represent y-axis is represented a different things in physics, right? Displacement, velocity, or acceleration. So always look at the units you have and also see what your x and y axis represent. Okay. Now let's see how I can calculate the velocity and acceleration based on these diagrams. Let us start with the displacement. If I have the displacement, I can average the velocity because the average velocity is delta x over delta t, right? So how it's gonna work, imagine I have 2 points as A and B. The only things in the average velocity I care is the first and the last point, right? So it's gonna be the straight line between the point A and B, and technically speaking, I don't care about the path, I only care about the first and the last point, right? And then I can calculate the average velocity. Also, I can calculate instantaneous velocity, which is a derivative of x over t. What that means, I have one point in my graph at C, and the slope at this point gonna be the instantaneous velocity. I talked about the average and instantaneous velocity in the previous video, and also I'm gonna put the link below. The second graph shows me the velocity respect to time, right? So I can calculate the average acceleration, which is the difference between velocity over time, right? Again, I have 2 points as m and n, and the average acceleration gonna be the straight line between the point m and n. And also I can calculate the instantaneous acceleration, which is a derivative of velocity over time. Again, I have 1 point at this diagram, and then a slope at this point gonna show me the instantaneous acceleration. Okay? Now let's look at one example here. Okay. This question asks me to find the velocity at any time from the slope of the curve, right? So here I have the displacement, and then I should find the velocity, right? So let's look at point A and B right here. Okay, so here I'm not trying to solve the problem and go to the values and then calculate it with the calculator. I'm gonna just look at this graph and see if I can find which one is the right one without solving the problem, if that makes sense for you. So let's look at the point A and B. So what I see here is like the slope is negative, right? So if I gonna choose these 2 points right here, this slope is negative, right? So the first answer I have here, like 1, the velocity is constant at 2, right? Which that's not what I'm looking for, correct? Let's look at B. For B, I have the velocity as a negative, right? Because it's like it's coming from 0 to -1, correct? And the third one, I have the velocity at this point right here is positive and also is constant at 1, right? So I can tell 2 is the right answer, right? But let's look at the other point as well, like between B and C here. So whenever we have a straight line in graphs, it doesn't matter if it's velocity or displacement. It means I have the constant of something. So what I mean is, if my plot is based on the x and t, then my velocity gonna be constant. If I have the velocity based on t, then that means my acceleration is gonna be constant. So here, what I see between point B and C, I have a straight line, right? So that means my velocity gonna be constant, which shows in 2, I have the constant velocity right here, and time is between 2 and 6, right? Let's look at the point between C and D. So here, my displacement is going to be constant, right? That means my velocity going to be 0, and this is what I have in number 2, right? Now let's see if I want to calculate this. So let's start from between point A and B. So I know V gonna be delta x over delta t, right? My delta t at this point gonna be 2 minus 0, and then my x gonna be 2, 0 minus 2. So my answer gonna be -1, which I found in number 2, right? How about point B and C? So my V gonna be delta x over delta t, which is equal to my x is 6 minus 2, right? And my t also gonna be 6 minus 2, so it's gonna be 1, right? How about the last point, like C and D? So here my x, my V equal to 6 minus 6, and I guess time, it doesn't matter here because at the end I'm gonna end up with 0, right? Now let's calculate the acceleration for this problem. So for the acceleration, I'm not gonna solve the problem. I'm just gonna look at the problem and see if I can choose the right answer. Let's look at number 1. So here it says my acceleration gonna be positive. However, what I see here is like this slope right here between these 2 points is negative, right? So number 1 can't be my answer. What about number 2? So the acceleration is negative, so it can be a right answer. And also the same with the number 3, right? So I have to look at the second point right here. So here between these 2 points, I have a straight line, right? So the straight line here means my acceleration at this time must be 0, right? So that means number 3 gonna be right, because that's the only one I have the acceleration as the 0, correct? So now let me calculate the acceleration to show you I'm right. So the acceleration between these 2 points, A and B, is gonna be A equal to delta V over delta T, which is delta T gonna be 2. And the velocity between these 2 points gonna be -1 minus 0, which is minus over 2 and is equal to minus half, right? This is for this point. And then the acceleration between C and D is equal to A, so time gonna be 6 minus 2, and then this one gonna be 2 minus 2, which is gonna be 0, right? And then for the last one, velocity is like between C and, let's say this is M, so between D and M, the acceleration is equal to 0 because my V is equal to 0, right? Now let's go to the conclusion of this problem. So the key in this type of problems is like if you see the straight line or not. So what I mean is like between point B and C, we have the straight line, right? That means my velocity between point B and C gonna be constant, okay? And you saw how you can also calculate it, but in terms of saving your time in the exam, you can use these kind of tricks, okay? Also, between point A and B for the velocity, we saw that a slope is negative. So we can say the acceleration is negative, okay? How about this point right here for the displacement? Between C and D, we have a straight line. That means my x hasn't changed between the first point and the last point, right? Which means that my velocity gonna be 0, right? I hope these tricks help you in the exam to save your time, and also you understand these subjects better. So if you like my videos, please hit the like button, and I'll see you in the next video.